Hey guys, so today we're going to talk about, as it says here up at the top, the trait system. So, I've designed and built this kind of stuff before. We had something very similar to this on The Sims, so, it's not going to be exactly the same, obviously. It's going to meet the needs that I need here. So, what I want to do first is just kind of talk about the motivation behind this. So the first thing is the idea is to have these kind of characters in this world. If I kill this and just start drawing stuff, so I might have some kind of entity that lives in this world, and you typically have some kind of component architecture or some other such thing. I want to be able to use that same idea of these components that are attached to characters, to entities, to attach functionality to them. So it might be what's a good example? Some kind of damage resistance, or it could be personality traits as well. So things like this person is very funny or particularly smart, for instance. Lazy. And so these can all affect behavior. For example, take this lazy person. This lazy person maybe will have, some percentage chance to be late. Things like that. So these are the various things. Yeah, insanity is another one. Insane could be another trait. And they can be any number of things. So one game that I happen to be playing right now is a game called Pillars of Eternity. I've started replaying that. Not really replaying it, but picked it up again. Let me see if I can find the character sheet view. I feel like my internet is going slow because I am streaming. Here we go. So you have someone like this, and if I zoom in, this is a terrible image. Maybe here's another one that seems better. If I zoom in, you have things like Faithful Companion, plus 15 defense against dominated attacks, things like that. Each of these could be considered a trait, things that affect you in some way. In a sense, these stats here could be considered traits. Any of these particular reputations and ranks could be considered traits. It's a number of things. On The Sims, we had traits that were personality traits. We had buffs and things like that. And those buffs were sort of a different thing, but they also affected AI and all of that kind of stuff. For my purposes, I think I'm going to just create a trait system. So traits are going to kind of rule them all. So I want to spec this out a little bit. In electrical engineering and other such things, you create specs for stuff, and in programming the same way. So you might have this AC adapter, for instance, and you can see that this adapter is rated at 9 volts output with 2 amps. And it's okay, cool. As long as I'm within this sort of guide, and that I'm inputting somewhere around here, anywhere from 100 to 240, which means that it's going to work almost anywhere. Japan is 100 volts, we're 120. Europe is typically 240. And as long as I'm not exceeding this, then I'm good. So we're going to kind of create a spec, kind of like this. Okay, so let's do that. That's our first thing. And we'll make this guy go away. Right. So first spec, first thing that I want to talk about with this little guy is some sort of architectural and performance concerns. What are the major questions that I need to be able to ask? So of a trait manager, that seems fine. What are the major questions, or what are the major actions that I want to be able to do? Well, I need to be able to add and remove traits, of course. I need to be able to ask the question, do I have a trait? So has trait. I need to be able to, in some way, iterate through the traits and in some way, sum them up or figure out those types of things. I'm not quite sure how that's going to work yet. Unlike, say, a lesson plan when I'm teaching a class, I actually have no plan. I'm coming up with a plan right here because I'm designing this. I think it's useful to go through this whole sort of purpose, this whole thing. Okay, so how's this going to work? Well, my hit is to have some kind of, trait component. So I have a sort of entity component architecture, similar to Unity. And so I think my hit is to have this kind of thing. And so these functions, like this functionality, essentially lives here. So this is essentially the trait manager. And I'll kind of draw this little box here. And it's going to have a bunch of traits. So trait looks like this. And I'm going to make this sort of bigger because there's more stuff here. And this guy's going to own these traits. I mean, the traits, this is where it becomes a little fuzzy of like, well, what's all the data and stuff that's going to be in these particular traits? Like, what does each trait have? And so we'll look at that in a second, but we'll look at what some of the data is. Some of the stuff that I know is we're going to have some kind of ID. I think we're going to have some kind of like display name. That feels right. We're probably going to have some kind of icon. These guys being optional. It's perfectly reasonable to have hidden traits. My pure experience tells me that we're likely going to need some kind of concept of a type. That doesn't mean like the individual trait type, but a lot of times it's better to categorize things as like a lot of times I want to say, get me all of the traits that affect work. Get me all of the traits that affect combat, that kind of stuff. So I think all of these types of things, I think that's the useful stuff. So we may have some kind of like type or maybe category. That kind of stuff can be useful. I don't know if we're actually going to have that. We'll see. And then like stuff, like how does it affect your stats? How does it affect schedules? Like does it add schedules? That type of stuff. We may have some kind of hierarchy. My plan is to probably not start with that. My general rule of thumb, and maybe I'll write these up here for architecture. Architecture. There we go. My general rule of thumb for things like architecture, and I'll just kind of have a running list here. Number one, I always try and start simple. What's the simple thing? Performance, by the way, is the same way. What's a simple thing? And for performance, it's like what's the kind of appropriate asymptotic complexity for the data structure that I want. So I'm going to start really simple, and I'm not going to have any kind of hierarchy here. It's literally going to be this component. This is going to slot, a lot of times in blue I'll put, engine level stuff. So this is just going to like inherit from my component architecture here. So this is great. So we're missing one other kind of major thing. And I don't really want to call it manager, so I'm going to call it a trait database of some kind. So what's this going to be? Well, this is probably going to have like some kind of map of trait ID to some instance. So there's going to be some way, I don't actually know what this data is going to look like, but what I actually want at the end of the day is some kind of create trait, some kind of factory. There's also going to be some kind of like load where it's going to load all of the data, right? We're not just going to like const expression our way through this. Data is super important and is probably the next thing we're going to talk about. So I'm going to say, it's actually probably not a diamond. It doesn't actually really have a reference. It's going to be an arrow. Specifically, this guy's kind of a factory. So you could think, I could call it trait factory, I suppose. But it is going to have like, a factory to me implies that there's not a lot of internal state, and this trait database is going to have significant internal state, I think. I could be wrong about that as well. Who knows? So, 'cause I think what I want to do is I want to be able to like load traits by ID, or maybe I'll create some traits and kind of clone them. I haven't quite figured that out yet, but we'll see. So that's kind of about it for the basic, just general idea. I don't want to spend a huge amount of time on this stuff. This is kind of the basic idea. And like I said, I'll keep coming back to this architecture thing as I sort of write stuff. So I think that's what we're gonna do. I think that's the idea. Okay. Yes, and so for the question that's sitting here in the chat, it's a tablet. That's what I use. Yeah, just like a Wacom tablet, like anything else. The program I'm using, you probably can't see it up here, is called Mischief, and it's a very good program for doing this kind of stuff. So it's really easy. No, I couldn't do this with the mouse. I can't draw like this with the mouse. All right, I think I've sat here and sort of stared at this thing long enough. This system is, I think, relatively straightforward. So I'm going to jump in code. A caveat to the code side of things. The caveat is I'm writing this as a system for a project I'm actively working on. So I'll kind of show the project very briefly. It's a project that I hope to ship at some point, but this is not like a tutorial for how to do this stuff, which means that I'm going to be hooking it into architecture that already exists. So if I just run this guy, it's going to show me this. Well, for funsies, I guess I'll keep this little guy up. That's my console window. So this is like my console window where I have cheats and things like that. You probably can't see much of anything. It's literally a Lua Lua console. I can type in, I can say x equals 10, and then I can say, print x, and it'll print 10. So it's just a window into Lua. So anyway, this is just a ship. So I can, you can create a ship, but that's not what we're worried about. We'll jump into the actual game itself, and here it is. And so, I have like tons of people. They're going to kind of wander. They're not really going to do anything useful. In fact, part of my goal here is to have them do useful things. Based on their current the current time of day and what the current schedule says that it should be doing. So like these guys are probably gonna go to these bed. Yeah, a lot of them are going to beds. They're sort of going to like relatively random things at this point. So what I want for these guys to have these traits attached to them so that they'll have different personalities and things like that. Obviously they're going to be more than just these sort of pawn-shaped programmer art things. But the idea is that you'll be able to click on them. You can maybe see it down here if I zoom in down here. Oh, off I go. But you can see down here I've got, I've clicked on a couple of these guys. And so this guy is crewman 3rd class Gavin Stockton. He is from security. This is Clay Mora, a 1st class petty officer who is an engineer. So we can kind of see who all these people are. And then the idea is that I'll have traits and stuff attached to those people. Let me go back up here. To give you a sort of stronger idea of kind of what I'm looking for, I'll show you an example of where I did this before. Oh no, I didn't build this. Well, this will compile. There it goes. We'll see if this works. I've actually run this in a long time. This is a prototype that I did. This prototype actually informed the current game I'm working on. So let's see. Come on, buddy. Oh, I'm at a breakpoint. That would help. Let's see. Let's kill all my breakpoints. There we go. Okay, so I don't have a grid. That's interesting. Something broke, so let me rerun this. Still don't. That's fine. I'm going to pretend that I have one. These black squares are people. So if I control-click on one of them, and I have to kind of go to a better place, like that sort of shows me what's going on. So for example, this is a medieval town. So this is a florist. So you can see here there's kind of this florist trait. I think it's going to be easier if I open another one of these guys. And do this, just so that I have one that's like alpha out, basically. There we go. So I've got this florist here. Oops, wrong one. Florist. So you can see that they have different traits. So if I go back here and I click on like this dude has an innkeeper. And so this will inform a number of things about them. Their schedule, for instance. So it informs like all of this kind of stuff. So I'm kind of using a lot of this stuff. And the system that I created was okay, but we're going to see if we can do better than that. So that's the idea. Like it can even inform like what your job is. So another question is, was this inspired by Faster Than Light? Yes and no. I'm going to say no. Because there's a tabletop RPG, which I'm super into. Tabletop RPGs in general I'm really into, called Battle Stations. Oh, good God. This is an epic map. This is not battle stations. Great. This is, though. This is a terrible picture, but where you kind of have these rooms of things, and you can build these ships basically out of components. This might be a better one. Yeah, here we go. So you have these like tile pieces, and you piece them together to build these ships, like this. And you have like people in them. I'm not saying. Oh, there's one. You know, there you can see them here. So you kind of have these people around, and I'll highlight some stuff. Like there's a person, and so these people they go to different parts of the ship. So this here is a console that you can sort of sit at. Like here's another one. Right, these are consoles that you can do stuff with, and there's more here, and so. FTL is very much like this game. So this game came first, then FTL. Amusingly, I talked to the guy who wrote FTL, and he says after he shipped FTL, he got tons and tons of people asking about battle stations. He's like, I've never even heard of this game. So he should go and play it. So take this concept, but this is also very much like a lot of games where, I mean, how many people are on this ship? 5. I wanted to take this and bring it to a more realistic level. If you look at an actual like Navy ship, you'll have 80, 100 people or whatever on it. Like a typical SSN might have, 80 to 120 people or so on it. Destroyer might have 120, 160 even people on it. So, an aircraft carrier has thousands of people, has like 2,000 or 2,500 people on it or more. So I wanted to get more realistic numbers. That was my goal on top of it. And also a hell of a lot more complicated than something like FTL, which is essentially a board game, and admittedly so. He designed it as a board game, or at least he paper prototyped it as a board game. So I'm procedurally generating the whole galaxy and so on. Let's see. So now what I want to do is I want to kind of dig into some of the code and that kind of stuff and just start doing stuff. No, I didn't finish any of the UI for setting managers or any of that kind of stuff. It'd be nice if I did that, but I totally didn't because I changed a considerable amount of things. I'm going to zoom in a little bit here. So what we've got here is the component system and the components. These are game-specific components. Many of you may not have actually seen this engine before. This is my own engine. If I kind of unexpand all this crap, you can sort of see how it's architected a bit, where I've got these like major libraries. These are my lowest level libraries, and the service libraries for like how I render and a resource system and stuff. And then the actual engine itself, which is up here, which is all this stuff. And then the game, which uses all of that. So you'll hear me often talk about things that are on a game layer or the engine layer, and that's what all that stuff means. So the trait system is going to live entirely in game code and be derived from the only engine system that's really involved here is the fact that it's a component system. It's part of the component architecture. So it is, in fact, a component. So the first thing I have to do, and this is not ideal, I'm going to be the first one to admit this, and I'm actually designing a totally different entity system, but it's a non-trivial thing to create, is I have to create... where are you? Space and Object System interfaces. I created sort of a strong interface, but it leaves me with some issues. This is a system I created, 10 years ago? Is that right? Yeah, about 10 years ago. So it's showing its age considerably. Anyway, I'm going to call this, I'm going to say trait haver, giver, trait something. I'm just going to call it trait component. That's fine. I'll take the coward's way out. So, trait component. Let's zoom this guy in so that people can actually see what I'm doing. There we go. All right. So, trait component. And the way that this works is that the top level interface is a pure virtual interface. This gives me an advantage in that I can have multiple different implementations of the same interface, which is pretty nice. To be able to do that kind of thing. For example, transform, it allows me to have a transform interface and then multiple implementations for the type of transform that I have. World footprint is another one. I have some world footprints that actually block off a tile entirely, and I have other world footprints that are just a bold suggestion. And it's really nice to have that. The big disadvantage, of course, is that you're basically about to watch me write, virtual and then a bunch of stuff. This has to derive from entity component, that guy, and then of course include all that stuff. And so if I go to entity component, I've got a bunch of stuff here that I can generally override. And so what I'm going to do just to start with is think about what do I really want? Well, my hit says it's probably a hash map or unordered map for those who aren't using EASTL. That's what I think this is probably going to be. So I'm going to create some kind of, hash map here. It's exactly the same as an unordered map. It's the exact same interface. So the hash map type is going to be, the key is going to be some kind of ID. So I'm just going to create a trait ID. The data is going to be a trait itself and probably a pointer to it. I don't know yet. And I may have to create a special hash. So traits. So these are the traits. And then in general, I'm going to go to here and we're going to have kind of these guys. Add trait, remove trait, has trait, and some kind of iterator. I don't know what that's going to be. So I'm going to say, void add trait. So because it's a hash map, incidentally, probably I'm not going to have duplicates. Maybe it's a trait pointer? Trait. Yeah, maybe it's just a trait pointer. I don't know what this is going to be yet. I like to just kind of stub in these functions. 0, because of course this all has to be virtual. And then we're going to have remove trait. Man, I'm fat fingering all these. Okay, remove trait. And then this is, of course, going to be probably by ID. That seems good. And then, what was the other one? Oh, has trait. I think I actually want to do this differently. I think I actually want to do trait star get trait. And then this trait ID. And then this can return null. And then that says there's nothing here. So this feels like kind of the interface that I'm going to go for. So what's a trait? Well, let's define that. And let's figure out where this is going to live. I have crew stuff here. Schedules, crew management. I think it's going to be its own thing. Yeah, I think it's going to be its own thing. So let's add a new filter that I'm going to call traits. I think it's important enough this is its own kind of guy. New item, and I'm going to say it's not component interfaces. Let's change all this stuff. New thing, traits. What do we want to name this? I think I'm going to name this, for lack of a better term, trait types. Okay. Trait types. .h. So one question is, what is the ID? What is a trait ID? And I'm not 100% sure what I want to do. I think what I want to do is I want to make it I think I want to deal with this by name. I think I want a user typed name here. So I'm going to say trait ID equals string ID. Some of you have probably heard me talk about this. Oh, you're going to want to include this. That will help. Some of you might have heard me talk about this in the past. For those who haven't, a string ID, I'll go to it. Briefly, a string ID is a type of string that is lightning fast to compare. It's optimized for comparison. So under the covers, briefly, it has this static map, basically, of string IDs. It's a set, specifically. So any string ID gets inserted into this hash set. And the idea is that if I have two string IDs, I'm literally, it's just a pointer to the string itself. So two string IDs are very, very fast. In fact, here's the complexity, right? Comparisons between two string IDs are constant time. A string ID in a string is a regular string compare. and some lookups. So there's a little overhead, but things like hash lookups, lightning fast, right? It's just a pointer lookup, or it's a hashed pointer that we're then comparing very, very quickly. So that's the idea. So I think that's what a trait ID is. That also means that I'm going to include this guy here, so that now I know what traits are. That's what I want, and for fun, so that I don't have little squigglies. Okay, so this seems like it's cool for me right now. If these guys are going to exist, I probably have to destroy these, so I'm probably going to have some kind of, virtual destructor, as we all know and love. Trait. And again, I'm not convinced, well, not equals default, I actually need to do something here. Okay. So now, of course, I need component implementations, and I'm going to do trait component implementation. This is the part that kind of sucks, because now I have to actually implement all this stuff. Component interfaces, trait component. Yeah, this looks right. Great. So we're doing this kind of thing. And then, of course, you inherit from trait component. Great. There we go. So that should work. If I go to trait component up here, I've actually screwed this up because this should have no data. This guy has the data, and then this guy would actually have the virtual destructor. Question is, do I use shared pointer or unique pointer? Nope. Oh, not equals default. I'm wanting override. I'm typing while I'm talking. No, I don't. There's two reasons. So I use smart pointers as a thing. There are two reasons why I don't use shared pointer. Number one, I think it's a cop-out in many cases. If you don't know the ownership of your objects, and you don't understand their lifetime and have no consistent owner, you probably have a bad architecture. I think that there are valid cases for it, and I think I use them in a few places. For example, my component architecture actually does use smart pointers. If we actually go to entity, it's object system, this is in the engine. It is, these entity maps is a strong pointer to entities. The entity itself has a hash map of strong pointer to entity component. So I do use them here because in this case, it's super useful to be able to just hold on to a weak reference. So my general rule is if I'm going to use smart pointers, I will have one shared pointer and only one shared pointer. Everything else is a weak pointer. That's my general rule. Also use them as little as possible because they're slower. Now, I don't use shared pointer specifically for two reasons. One, I wrote a smart pointer system long before C++ had a smart pointer system. The second reason, and I'm like, hey, maybe I should actually use it, is this. I did a performance analysis, and my smart pointer system is, in many cases, significantly faster than the EASTL. It's slightly slower in one instance, although, amusingly, in 32-bit mode, it is faster. But weak process, which means I'm dereferencing a weak pointer, is sort of a nightmare in EASTL. I mean, look at that. 27.78 versus 3.67. It's just no contest. And weak process is one of the most common things that I do. So performance. Shared pointer is more robust in many ways, but my smart pointer system works for what I want. I have two major constraints. Number one, it is not even remotely thread safe. So I cannot have smart pointers across threads, which EASTL or regular C++, it's not 100% thread safe, but it's more thread safe. That's why there's shared pointer versus weak pointer, and why you have to create a shared pointer in order to dereference a weak pointer. Number two is, or this is number two, right? Number one was that I already wrote my own system, and I'm like, do I really want to excise it from my entire engine? It's, it's 640 lines of code, so it's not crazy. It's not too bad. It has broken on a couple of occasions, but it's been pretty good, especially since the refactor. Anyway, Unique pointer is I don't use unique pointer entirely because because it didn't exist in C++ for a while, and I simply haven't gone and like, okay, what needs to be a unique pointer? Unique pointer is the exception in that it's, except in one edge case instance, it is basically just as fast as a regular pointer. So I would use unique pointer as much as you possibly can, really. Anytime that it's appropriate to use unique pointer, I would use it. I don't do that, but don't do what I do, I guess. I should go back and make those changes. Anyway, if I go back up here to this guy, I actually don't need to declare you. And then I have to go here and override these guys, which is, super fun. Sometimes I write a little macro that does this. Okay, so now I have a bunch of stuff here. Okay, it's time to step back from this for just a minute and go to my little data folder here and figure out what this is going to look like. Data. I think, do I want it to be its own thing? Or do I want it to be like in here somewhere? I feel like it's probably its own thing, or it's in tuning. I'm going to put it in tuning for now. Open containing folder. Okay, I don't need chip parts. So, just for now, I probably should put it somewhere else, but I can refactor later. Oops, not a folder. I'm going to create a new file. My data format is Lua. A lot of people use XML. XML is probably standard. And every company I've worked at, we get to some point where the XML is too crazy, and then someone has to go in and spend a whole bunch of time optimizing it, and then there's usually some converter that converts the XML into some like flat binary format, and then nobody even touches the XML, so XML becomes this intermediate format. So you write a tool that spits out XML, which then gets consumed by some data build process, which then gets consumed by the engine. So I'm like, that seems terrible. Maybe I won't follow in those footsteps. JSON is the same way, by the way. So let's do something else. I'm going to say trait, I don't know, trait database, traits is fine. And use Lua. Lua is just my data format because I already have all this stuff that I need for it. Let's throw it in tuning. It's sort of a weird place to put it, but that's okay. This sort of feels like the wrong place to put it, but that's okay. Let's just do this for now. So let's think about what the data might look like. And I like to pretend as if the data already kind of exists, or as if the system already exists, and just write data as if I wanted to write a bunch of these traits. Traits.lua. And so I think it's just like __ traits. I usually use this sort of like double underscore thing if I'm writing like a big data table somewhere. No. So it's just a big sort of data table. I think I'm going to do it by probably name. So I'm going to say, I don't know. I'm going to say security rating. That might be fine. What might that look like? Actually, let's do it by shift. So I'm going to say alpha shift. Because what I'm actually trying to do is set up, what am I doing? Alpha shift equals. Is set up shifts. So there's three shifts. There's the alpha shift, the beta shift, and the delta shift. And so if you're on the alpha shift, then from 0800 to 1300 or whatever it is, 12 or 1400, you're working. Sorry, it says 16. That would be 1600, wouldn't it? So from 0800 to 1600, you're working, and then the next sort of shift, you're doing whatever you want, and the next shift you're sleeping. And then beta shift is the same thing but shifted. So they'll be working at the second sort of shift, and then delta shift is shifted again, so they're working at the third shift. So it's sort of 3 8-hour shifts, which is not in any way realistic to how the military works. There's sort of two major ones. There's surface ships, which have sort of these weird 4-hour kind of watches. And then there's submariners, which are in 18-hour cycles because they never see the sun, so it doesn't matter. So you're 6 on, 12 off. So anyway, this I made this as a concession. So let's create a few of them. Delta shift, beta shift. And so these feel like work traits to me. So I think one thing that I might want to have is some kind of type, and maybe I'll say work. So it's the same for all of these guys. And then I think I want to have some kind of thing that's like schedule equals, and then I need to have some kind of like schedule thing here. So maybe this is the schedule ID. So I'm going to say alpha shift, and I have a schedule ID, a schedule data thing somewhere. Schedule, where are you? Oh, there it is. Schedule entry database. Work as engineer, and then somewhere here I thought I had some shifts. This is the entry database. I may not have created the actual schedule database yet. Here they are, schedules. Schedule templates, here it is. Alpha shift enlisted, that's what I want. So these are schedule IDs, and to find when they work, you can actually see their start and end times. Cool, so this is what I think I want. Alpha shift. Beta. Delta. And right now we're mostly going to ignore these things. Oh, whoops. That wasn't what I wanted. This is what I wanted. So we have to also kind of consider what else is going to be here, right? So I could have like AI modifications, scoring modifications. I'm just going to add some stuff here, like scoring mods for AI, you know, relationship modifications. I mean, just like stat modifications. You know, all sorts of things could be added in here. For now, I'm just going to try and do this sort of type. And I'm going to create another one that's called tagged equals, maybe I'll call it test or something. I'm going to say test tag. And I'm actually going to create a little section for it. You know, you have to create test data a lot, and it's always good to try and cauterize it a little bit so that it's easy to get rid of. These are work traits. Okay, anyway, and this isn't even going to have any. I'm going to say type equals test seems reasonable. This doesn't really matter. So right now I have kind of a couple of sort of data things that I know that I'm going to want. And so I think this is going to work for me. So overall, I want to have some kind of database that's going to hold on to this stuff. So let's start adding some of that stuff. Oops. I'm going to actually add the things that I'm pretty sure I'm going to need. So I'm going to need a trait. So here's my trait class. And then I'm probably going to need my trait database class. I think this is probably what I'm going to need. Okay, so trait database. So the trait database, from this sort of high level, well, let's do trait first. I think trait's going to be easier to understand if we do this. So for traits, we're going to need to include trait, no, not you, trait types. And let's talk about what we want for traits. So as I said, a trait probably knows its own ID. A trait probably has literally like some kind of string name, display name. It may have some kind of like, you know, texture resource or whatever. Like I'm probably actually say like resource proxy. How do I want to put this? I guess just, I'm going to say, I'll just say icon, screw it. I'm not going to do that now, but I'm going to throw it here as a comment so that I remember to do this later. And then we need some kind of trait type. We don't know what that is yet. We know that that's going to be here. I'm going to actually put this next to ID because that seems a more appropriate place to go. Let's go to trait types. Figure out what these types are going to be. I think it's going to be enum class like trait type. Like I think it's going to be an enum. This feels right to me because I think there's going to be a very finite number of traits, trait types, and I don't know what they all are yet. But I think I can make a few up. I think I can have an unknown type that it just defaults to. I think I can have a worker type. For those of you who are students, you may notice that I'm not following the coding standards of the GAP program, and that's because I use different coding standards. Social story. I don't know. These are just some things that I've kind of thought about. Like, this seems good. Anyway. Num traits. That feels reasonable. At least as a start. Okay. What else do we want to do? So, probably, I'm going to say schedule ID. Schedule template. That seems reasonable. You know, and all the other stuff that we want is going to kind of be here. Okay, so we're going to need some kind of constructor. I'm going to say, do I require anything? Maybe not. I'm going to say mtype is trait type. We'll default this to unknown, and we'll leave everything else, I think, default. I'm going to give it some kind of initialization function. The way that I usually do this is with what's called a script variable. I'm going to say definition. And so a script variable is literally just any variable that comes from the script, that comes from Lua. And in this case, it's going to be, whoops, where are you? This guy, this table. Okay. So, you know, that's what I've got. And then, you know, some kind of implementation of, I probably want this to have some kind of behavior when it attaches. So like something like on attach to entity. That seems reasonable. I don't know what exactly I'm going to add to this yet, but this seems like a reasonable thing to maybe think about. So this is kind of how I approach things a lot of times, like on remove from entity. I might just say on attach and on remove. I don't know yet. Okay, but I definitely know that I want to create some of these like accessors. And, you know, these get kind of boring, but const trait ID, you know, get ID, const return MID, const ASTL string, get display name, and so on. And maybe I want, let's also do the type. Create type, and I don't need to be const or any of this crap. Const type. That's probably all I need for this. And then I know that I'm going to need some of this crap. Okay, so I'm going to write the code to actually load this guy. I think this is the only thing I need, so we'll go ahead and do this. Generate implementation. Cool. Okay, so what I want to do with this init is I basically need to kind of go through the data itself. You know, I don't know how super interesting this is going to be, but, you know, I'm loading data. So I need to first go to script interface. Where are you? Oh, you're at the top. Script helpers. Of course you're at the top. I use this all the time. And so what are the different data types that I've got? Where's my trait Lua? So it's going to load this thing, and basically I'm going to get, my plan is to get this table right here. So if this is happening, I may not actually have this ID, so it might be reasonable to somehow send this, but I'm basically going to be loading these two things. So strings are sort of wonky, so I have to kind of load them like this. I'm going to say temp equals null pointer, and then I have to do my script parse string, which takes in the definition and pointer to the string. So there's a pointer to a pointer, basically. The key, which is type. And should I show an error if it's nil? Yes, I should. And let's say if this is not equal to script parse, parse result. So if I didn't succeed, then we return failure. I don't need to print a message here. So these parse functions are super cool. I remember I spent a few hours writing them, and I'm like, I wish I wrote them years ago. But they're just parsing functions to parse like pieces of scripted data into things, or just convenience functions to like parse a bunch of data. And they print out error messages and all this stuff. So they're super useful. If you're doing any kind of like significant data processing like this kind of thing, I would recommend it. Okay, type. So if I get here, then I know that I have it. So then I'm going to say mtype equals, get, what is it? I'm going to say get type from string ptemp, right? Because I just don't feel like dealing with that right now. And then I'm going to say display name. And I'm basically going to copy and paste this, because it's pretty much the same, except I don't need to define this. I'm going to reset it to null pointer. And then I'm going to do a parse of the same thing, except this time I'm going to call it display name. And then this time I don't care if it's not valid. So then I have to switch this around to invalid type. So in other words, this will now succeed. So the different types are unset, which obviously is not good. Success, invalid type, and nil. So success and nil are now valid for name. I don't care if it doesn't have a name, so it'll just skip it. And then I'll basically say if ptemp, so if we did load something, equals ptemp. That should work. That's it. We're good. We'll have to load more stuff here, but this is fine for what we need right now. What did I name you? I think I can do this from whatever, peak definition. I actually never do this. I do this the hard way, but I feel like there's like an easy way to say like create function from context. Maybe it's a thing over here. Create member function, get type from string. Oh, this is going to be good. Let's see if this works. Well, it put it up here, which is not great, but let's put it down here. This is good, except I want it to be const. And it didn't actually create anything. Cool. Well, that's fine. I don't know how much time that saved me. This is awful. And no, not even this. I don't even want this. I want, this will be fun. You guys have never seen this before. switch, ptemp, scase. And the case in this case is going to be basically all these things that I feel like they should be. Trait types. Of course you can assign to a const character pointer. Why can't you? Actually, I wonder if this would work. Because I'm doing it indirectly. This may not build because I have a bunch of other stuff going on here. Let's just compile this one file. Yeah, it's fine. Because I'm doing it indirectly, so I'm sneaking it in. Right, because I'm passing a pointer to the thing. That's it. You can actually do that with anything. Right, you could do const int foo equals 10, and then you can say int star. This part may not work because they're different types. Yeah, this doesn't work. The answer is yes, you can, as you can see, unless I'm wrong, which I might be. So unknown. Return trait type unknown. Right, and this is not super fun, but this is the price that I pay. Because, like, if I thought I was going to have a whole bunch of these, I would do something different. There's a lot of different ways that I can sort of make this better. I thought it was sdefault. Am I wrong? No, it's sdefault. Oh, there we go. And then it's end switch. You may be wondering what sort of magic C++ thing you can do in your own world to make this work with this like string switch statement. And the answer is you can't, because I wrote it. It's this. Basically, I got sick of writing a bunch of string compares, and so I wrote a switch statement. And I wrote this a long, long time ago. And it's kind of lame and kind of hacky, but it works. And it's fine. And it's literally it's syntax sugar to make this look more You know, what do you want? This thing isn't happy. That's fine. It's probably this guy. S default error. You know, invalid. Invalid. Come on, type string. And this is not going to be an AMP temp. And then I'm going to return trait type unknown. Trait type unknown. There we go. And we'll pretty you back up. That looks good. Let's not name this something terrible. We'll say P, I'm just going to say string. That's better. And then string. Okay, that's it. If I had a bunch of these, like I said, I'd do something totally different. But I'm not going to. Okay, so this is probably fine for just this kind of first pass of a trait. This seems like it's okay. So a couple questions. When you have sort of coupled systems in some way, for instance, you know, I have like, I'll do this in another color. I have like a thing, and I have like some, you know, other thing. And like these guys are in some way attached, like thing, you know, specifically in this case, thing owns this guy. And in this particular case, one question is, but I want other to like modify some stuff on things. So that's what we're specifically trying to do, right? If I have a bunch of stats, for instance, if I have strength and dexterity and all these things, I want to be able to modify that just by attaching this trait, right? So how do I do that? So option number one is thing asks other. I don't know if these abstractions are helping. Screw these abstractions. Because it's an entity and a trait. So the one thing is that the entity, or whatever it is, right, the trait component can ask. So, you know, entity asks trait. Hey, buddy, like, let me get all these things from you and see if you modify different things. Option number two is trait pushes onto entity. In other words, the trait knows, each trait individually knows what it needs to modify, and so it then pulls the things that it needs to be able to do that. The advantage of number one is that the entity controls it. And so probably the way that I would implement this is the entity component, the trait component, would send a notification that says, hey, some trait was added. Do you care? And then each component would say, okay, yeah, I care. And so it sort of keeps that stuff separate. And the trait doesn't have to know anything. It just contains data. Option number two, the advantage is all of this stuff lives on the trait, and then traits in turn can have their own hierarchy and so on. Probably, my current thought is that we're going to do number one. Specifically that we're going to send a notification to all components when a trait is added, and probably another one when it's removed. And it says, hey, this thing just happened. Maybe you care. So I think that's what I want to do. So that's good for this. So that means that this whole on attach, that's what this was answering. I don't think I want any of this. I think I want it to basically be pretty much a purely data thing. So that having been said, should this be a struct? And the answer is maybe. I don't know yet. Make all this stuff public? Maybe. I think probably not, because what it buys me is really this is all constant data. So then that tells me that what I may actually want is some kind of trait definition and then some kind of trait instance. And a trait instance looks like this. right? This seems like it might actually be what we want. Probably it has to have a definition. So we'll make that explicit. Right? Like this feels more correct to me. Because here's the other thing is like probably I'll have like timing data. Like I could attach like so let's take another example. Let's say that, you know, I have like a dude here and he has a power of casting some spell on these other dudes who are here, right? So one way to make this work is that these guys could sort of get these like temp effects on them. And those could be timed, and then after the timer goes off, they go away. So I'm liking this more. This may be better. I think I like this more. Because I have, you know, I'm going to have 500 entities, 1,000 entities in the world. They could all have traits. So instead of incurring the cost of all this, if this is all const data anyway, constant data that can never change, it probably doesn't matter. Yeah, this is a oh god, what is that? Someone who's tuning in right now might actually know the name of it. What is there's a design pattern. This is an actual design pattern. I want to say it's the flyweight pattern, but I don't think that's actually true. Whatever. Someone will probably chime in the chat and remind me what it is. I don't remember what it is off the top of my head. But this is an actual design pattern. Timing data or whatever this is. So this is pure instance data. This is all the data that never changes. This feels like it's probably right to me. Okay, so let's move on. I'm liking this more and more. Okay, so trait database. Let's talk about what the database needs to be. So the database is going to have some kind of, I think it's going to have like every trait in the world. So I'm going to say traits by ID or something equals EASTL hash map. Okay, yeah, you did the right thing. Trait ID and trait definition. And so it's going to include trait, and that's fine. And then we're going to say, it might help. Oh, no, that's right. Traits. This is sort of terrible. Trait definitions. That seems right. Whoops. Trait definitions, M definitions. And we'll write it all out. Trait definitions. So we have some hash map of every trait definition in the world. Now, if this database gets massive, which I don't know that it will, but if it does, then I have to think about other ways of like, you know, lazy loading or only loading when I absolutely need to load and stuff like that. But this is probably going to be okay. And again, you know, back to my, where are you? Not you. You. Back to my sort of list here. Start simple. And this is true for everything. So we'll just do the simple thing. Okay, what do we need to do here? Well, we have every single trait. I might want some kind of like by definition. I don't know. Or by type. I don't know yet. My suspicion is that I'm going to need other views into this data. And there's a lot of ways to do that. So I'm going to need... I don't need a destructor, do I? Not yet. Okay, so I'm going to say load traits. I think it's just going to know what the traits are. So that's fine. So we'll load traits. And then I'm going to actually say trait. How do I want to do this? Instance. Probably pointer. Create trait. Instance. Const. And then I'm going to say trait ID by ID. And now that we're using string stuff, I'm going to actually do this. This feels probably okay. That's probably all that I need. I probably just need these two functions. This is essentially turning into a sort of heavyweight factory. So let's create a bunch of, yeah, that's what I want. Create a bunch of definitions. So again, let's see how we're going to load this. Now, if I were writing this on the engine level, I would have like a whole thing for like tuned thing for figuring out like, well, what's the actual, you know, file path and all that stuff. But I'm not. I'm on the game layer, which means I can take a few shortcuts, and this is going to be one of them. This shortcut is going to be the trait database, resource path equals, and that's going to be, right now, it's tuning slash traits.lua. And I'm going to go back to tuning. So I load it down here, and I actually think this is the wrong thing. I want to explicitly load it. Yeah, that's right. And then I'm going to do the same thing, except this is going to be trait database table name. So these are just constants that I'm just throwing out into the wind, because why not? You know, again, if this were a, where did I put it? Traits.lua. If this were some kind of like system that I was building in an engine that multiple games would be using, I would care. In this case, I don't care because it's a game-specific thing. So I just create a constant for it, and I'm okay. This is not a thing I need to ever tune or touch. Okay, so load traits. This one's going to be pretty straightforward, mostly, because what I want to do is I need to create this sort of... So I need to go through my resource system. And I don't know how useful it is for me to like explain how the entire resource system works, because there's a lot going on there. So what I'm going to do is I'm going to just hand wave over it slightly. Should I do this as a resource ID? I don't think I should. Yeah, that's fine. Okay, so what I'm going to do is I'm going to say resource ID. This should only happen once. Yeah, you're fine. Resource ID, resource ID. For various reasons, I can't really do this here. I guess I could make this static, but that's fine. Okay, so resource ID, trait database path, and then I'm going to say resource manager cache resource. And the resource I'm going to cache is, of course, my resource ID. And I have all these other cool options. To signal loader thread, do I want to signal it? I don't, because I'm going to signal it in the very next line. I'm going to have a resource listener, which I don't need. I don't need my resource listener. Oh, yeah, I do. What am I thinking? I need my resource listener, but I need it to be... shit, I have to actually create all this, don't I? Okay, fine. Here's where you get to see me use pointers, like smart pointers. Okay, so strong pointer, simple script resource listener, because I have to actually care about this. Yeah, I know there's a bunch of stuff you want to include. That's fine. MP resource. I'm going to say MP database resource listener. Okay, so resource listener is, resources are loaded in another thread. So I need to be notified when the resource has been loaded, and I need to do something with it. In this case, I have an engine level thing that's called simple script resource, and literally all it does is loads the resource, runs the Lua script itself, and then flushes the resource. That's literally all it does. That's all I need it to do. Because I need, once this resource has been loaded, that this script exists in Lua. So I just need one of these guys. And I think this is the only thing that I need. So what I'm actually going to do is I'm going to say MP database resource listener equals new, this guy, right. And then I'm going to cache this resource passing in this guy. And then I'm going to say resource... I'm going to synchronously load this. I may choose to change that later. So I'm going to say, where are you? Signal, oops. Signal loader thread and finish loading. So this is a synchronous resource. Or not resource. And so now, whatever it is, it's been done. So now I'm going to say script var. Let's see, trait database, come on, database table, equals script get global. You should be fine with that. Get global trait database table name. So this is going to grab that table. Once this table has been loaded, where are you? Trait database. Oops, not you. Once this table has been loaded, it's basically going to grab this table, and then I can start doing stuff over it. Okay, so script get global. This doesn't really want to be my friend, does it? Fine. Get globals dot. Oh, I know it's wrong. It's not automatically including it for me. So script interface script. That should work. Oh, what's wrong with you? I guess it doesn't have it in here. This is not what I want then. Is it script manager? Okay, I've forgotten where it is clearly. Get globals. Let's see. Here it is. It's in Lua Manager. Lua Manager. Get globals. Yeah, it's this guy. This can't be the only place that it exists, though. Come on, where are you? Lua State. That's probably what I want. Yeah, that's what I want. What are you? Script var. Okay, script var has it. That seems like the most appropriate place then. I just had to remember where this thing was. Oops, not you. So it's not you, it's script var.h. So now you should have this get globals dot. You're killing me. Where is it? Okay, couple of vars. There we go. Dot get table value. Not value. Get global var. That guy. Okay, that was a thing. And then I want to say if trait database. So I want to check to see if it's nil. So if it's nil, then whoops. Come back to me. If it's nil, then we print out an error like couldn't find trait database table. And it failed. That should be it. Okay, so if we get here, we have the database table itself. So this is going to be load. It's going to be load the table resource, and this is going to be grab the table itself. And now we're going to basically loop through this entire table. So for well, auto, that's the easiest way to do this. Key value pair in trait database table. I'm actually going to change this and say if not is table. This has to be a table. And then I'm going to say couldn't find trait database table. Couldn't find database table. Type is plus trait database table dot get. Come on, type name. There we go. Oh, you're a string, so I have to do toString. Cool. Okay. Now, anyway, we're back here. Prototype pattern. That sounds right. Yeah, it could be that. That feels right. Except I'm not really cloning objects. It's an actual thing. All right. This is the prototype pattern. Is this right? Kinda. It loads some cached thing. I feel like it's like the flyweight pattern. I may be wrong here. Yeah, you have sort of shared and unshared data. It's the flyweight pattern. Yep. We used it quite a bit on The Sims. We had, for example, sim definitions and sim description and sim. What was the other one? It's just sim instance or just sim basically. Okay, back to this. So I'm going to loop through this table, and which is kind of nice that I can kind of do this. So this is actually going to create a type called a table iterator key value pair. And so the key value pair is going to have the key and the value. So if we go back to table, which is, where was I? Traits. If we go back to this table, key, and then the value is the next table itself. So now what I want to do is I want to basically say m trait definitions dot m. Well, I might just generate it. So trait definition. Because I'm already loading this guy. So I think I want to say definition, or just, yeah, I'm going to say trait def. And I feel like that I definitely want to kind of dot get key dot get string. I think I definitely want to do this. What are you complaining about? Oh, you're probably complaining because this is just wrong. So trait definition has to have an ID. Trait ID, we'll make it const. I think it has to have an ID. And so then, of course, if we're doing this, we want to make it probably explicit. There we go. That's better. What are you complaining about? That's fine. Since we're doing this kind of thing, I think I also want to be very explicit about what's going on here. So why don't we say trait... what are you doing? You know what I would love is I'd love a single button that says generate all of the 6 like random C++ functions that C++ creates for you. Oh god, okay, so trait definition const equals delete. So I'm just creating the magic functions. I want to not allow it to be copyable, so it is not copyable. But I'm okay. Where am I? This guy. But I'm okay if we move it. And I think I'm just going to say equals default. I'm not doing anything special here. Trait definition operator equals. So no copy, yes remove. Trait definition equals default, just so that I have all of them created. Why don't I create a snippet for this? The reason I don't create a snippet for this is 100% laziness. I mean, it's 100% laziness. That's why. I should, but I haven't, to be honest. I probably will since you called me out on it. Now that you've called me out on it. And I actually just realized just now how much of a pain in the ass it is to like, okay, generate these same, you know, the magic things. So I should probably create a snippet for it. A snippet, for those who don't know, is a Visual Studio snippet of code that you can just insert. Okay, so trait definition, M definition, all that. So okay, so now I've got all this stuff. So now I can basically do this, and then I can say trait def dot init, and we'll initialize the thing based on this. So this is going to be key value pair dot get value, which is going to be the table that we're passing in. And I'm going to say if not, because this is going to return a Boolean. Then, of course, we have some sad face, so error, couldn't load trait, and then I'm going to say this thing, yeah, that thing. Oh, is this right? Yeah, that's fine. If I could get string. Oh, I know what's wrong with you. Yeah, that's fine. Okay, so to stir, because it's going to do that. Okay, great. So couldn't load trait, some trait. I'm going to say couldn't load trait definition. And now here's a question. What do we do? I don't know. We could just continue and say, well, I guess that trait ID doesn't exist. It's cool, and try and load all the other traits. That's option 1. Option 2 is we fail. We fail the whole load. I think for now I'm going to try and recover gracefully, even though this is bad, hence why it's an error level thing. Okay, so if we get here, then we know that we're good to go. And I'm going to emplace... Okay, so I've already kind of done this, so I'm actually going to... I think I'm recreating string IDs all over the place. So I'm going to say trait ID. Oh, not string ID. I want to do trait ID in case I change this. Trait ID, we're just going to like generate the trait ID here. And then we can pass it in here. And then use it here. This is going to be better. And then use it here. Trait ID. And then I want to do standard move, trait definition, and then that's it. So then we basically move in the trait. And that should be it. This should load our data. The last thing I need is success. And that's it. Now let's create our trait instance. So trait instance should be straightforward. I should be able to do, something I was putting off. Hold on. Okay, so within here, it's not actually quite this easy. Because who knows what the data is going to be? It can be anything. I am often quoted as saying, I feel like I write more error checking code than actual code. So let's write more error checking code, because that seems fun. Okay, so key value pair dot get key. And in fact, we could even do this. We could say const script var key equals key value pair dot get key. I mean, this is just going to make things a little neater in release mode. This shit's going to be optimized out, so it doesn't matter. Let's see. Yeah, my entire job is checking for null. I feel like that's not an untrue statement. Okay, so if key dot, so what do we care about this, right? Key dot is string, not is string, then error, key is invalid type for trait. Oh god, I don't have anything. So key is invalid type for trait, because I'm not going to have anything here, plus key dot get, no, not get string, what am I doing? Get type, where are you? Oh, it's right here, type name. And then I have to string this. And I'm going to continue, right? This is certainly an error. Same thing, except value. If not value dot is table, value is invalid type for trait key. I'll actually create the ID here. So I can just do trait ID. Oh man, okay, so whoops, plus trait ID dot get plus value type is, there we go. Okay, good God. So check to see if the key is valid, not value, valid. Create the ID. Check to see if the value is valid. And then I want to create the definition. Add to our map. Cool. That for loop became significantly longer, didn't it? Okay, so now we want to create. Cool. Database. Oh, that wasn't what I wanted. Oh, the database listener. Where are you? You're here. I don't care about you anymore. MP database listener resource listener equals null pointer. I can just set it to null pointer because it's a smart pointer, so it's going to go away. I want to explicitly destroy it here. This actually makes me think, why am I doing this? I'm doing this out of habit. Right? Like, I don't actually care about this anymore. I'll just make it a local variable. Oops. And then I don't care about it explicitly destroying it. What do you want? It may be const. Sure, why not? Okay. That works for me. And I just don't feel like I need this. That also means that I can drop this guy in here. Most of the time, put you here. Most of the time when I'm creating these listeners, I actually do want to keep them around for a while because things will be consistent, like constantly loaded. But in this case, they're not. So just out of habit, I threw it as a member variable, and I just don't need that. That's just stupid. Okay, so create this. Oops. Trait definitions dot find. What did I name? ID. So auto find it equals this guy. If find it is not equal to database.end, then good times. Return find it dot second. Oh, how am I doing? I'm doing the find. Nice job. I'm totally ahead of myself. What I'm going to say is I'm going to find it dot second dot create instance. That seems good to me. And I'm going to say return. Else couldn't find trait with ID dot get, and then we'll just return null pointer. That's a failure. Cool. So now I need to go to trait and create the actual thing. Cool. This is looking good so far. So in my implementation here, I'm going to say trait instance star. Create instance, maybe const. I feel like const. And of course I need to for declare it. I might pull these into separate files. I haven't decided yet. I feel like I probably will. Okay, so create instance. This is pretty easy. Trait instance star p inst equals new trait instance. Pass it myself. Oh, it can't be const because it can't change. That's fine. I don't think I need to change it, so we'll go ahead and make it const. Anyway. What are you complaining about? It's not used. It will be, so I'm not worried about that. Okay, that feels better. Return p inst. Hooray! Oh, I screwed all this up, didn't I? Trait definition. There we go. Yeah. So create instance is pretty trivial. It literally just creates the instance. You know what? Take that. Okay. That should be all that I need here. I'm gonna mirror some of these guys. Maybe not all of them. These are just pass-through functions, nothing special. There we go. Now you are you, so you should stop bitching. Fine. Should be it there. Cool. I think we're good here. I'm going to hit Control F7, which just compiles a single file, which is what I wanted. Let's go to trait database. Oh, wait, create instance. What? It should be here. Find it must have a pointer type. Oh, is it this? Well, what are you? find it. Oh, is it you? Yeah, it's you. Right. And you can be gone, so that's fine. Okay. Hooray. So that's right. So it's going to grab the second thing and call create instance. This should be good. This should be good. I'm going to compile this and see what happens. It doesn't build because something's going on here. Oh, I know it's wrong. It's this guy. So the problem here is technically trait ID is a string ID, and it doesn't know how to hash that. Fortunately, I do, which is, oh god, EASTL string ID. Ah, shit, I don't remember what I named it. That means I have to go spelunking because it's been a while. Let's do that. So up here in the engine level, in utils, I want to say string hash. No, that's not it. It might actually be under string ID itself. Yeah, here it is. String ID EASTL. Here we go. Standard hash function. This is the hashing function for EASTL. Literally, all it does is it hashes the string as it normally would go. I'm considering having it hash like the pointer. I don't know. So this is, obviously not going to be as performant because it has to do this loop. But that's all right. I'm not too worried about it. It's a thing I can optimize if I care later. So I need to include it, and it's already included, so I'm good. So I just need to tell it, like, hey, use this hashing function. So that's why it was complaining. And that's it. Okay, so database and all this stuff builds correctly. So that's great. So I think that's what I want to do for just traits and all the other stuff. Okay, we're getting there. So somewhere I need to actually, like, create and load this trait database. I have a high-level logic system that exists here where, like, various things like this. For example, here's my schedule database. So I'm just going to put it here, trait database, trait database, and you are actually loaded somewhere down here. Here we go. Trait database. So I'm just going to add this entry, trait database dot load traits. I'm going to say if not. If I can't load the trait database, we're screwed. So I'm going to bail. I'm going to fail the entire load. Speaking of which, okay, you're void. Is that it? I feel like that's it for this guy. So that's going to load the database. So then I should have all the various traits and things that I need in the database. And all the traits should be there. My component may not build. But what I want to do now is I have a sort of path from, data to not data. Oh, you're the same issue, aren't you? Let's figure out, where are you? You're probably in here. Yeah, it's the same thing because I changed this. Oh, that means I have to change a bunch of this, don't I? This is back when I was thinking it was a number. It's not going to be a number. Who knows? I might change into a number. And then I have to go here. This is why the interface method is annoying. I actually use it very rarely. I actually take advantage of it very rarely. I have to completely rewrite my whole entire entity system. It's a pain in it's sort of fine, but it's a pain in the ass. Okay, so that's it. Now I can at least build this, and I can get an error that says shift enlisted. That's pretty cool. Invalid type string shift enlisted. So that means I think I screwed up my data. I think I have a copy and paste error in here. Yeah, I do. These are all work types. Come on. Oh, I don't have to compile, do I? Good job. Invalid type string test. Fair point. Invalid type string work. Really? That seems wrong. Pretty sure I created work. Worker, good job. Work, social, story, unknown. Okay. The folly of strings. Oh, that's going to bother me. There. Oh, and they're all returning unknown. Good job. Oh my god. I actually want this to be work. That's much better. Okay. So this means that I'm not building the entire system. Like, I'm building some piece of it, and now I'm testing it to see if it works. And supposedly it loaded. So let's load and let's run this guy. I mean, it's not going to change anything. Nothing crazy is happening, except it took a long time to load those textures. So let's go to... oh, what's a good thing? You know what? I'm just going to do this. I'm going to rerun this guy. Okay, so my trait database should be... oh, I'm in autos. Whoops. My trait database should be loaded, right? We expect to have 4 traits, and there they are. You guys probably can't see this at all. There we go. So I expect to have these 4 traits. May look a little wonky because it's EASTL, but it shouldn't be too bad. It's basically showing me the array, so that's why there's several of these null entries, and then a couple of these entries where there's sort of multiple things. This one only has the one. Which one are you? There's so much here. Okay. Test tag. So that's one of them. This one has the other 3. So way to go, hashing function. Strong work. Although I guess to be fair, they're named very similarly. Delta shift, right? Okay, so I assume that it feels like that they're all here, which is good. So if I drop this and go to second, so here's the ID, has type of work, this is the display name, which I don't think I actually have. Yeah, as null. So it looks like it's working and it looks like it's loading my traits correctly. So that's great. There's not a lot else that I need to do except to actually be able to attach these types of traits. So let's go to our, where is it? We're almost done. 9, 10, 11. Yeah, I said there's going to be 2 hours, so I have half an hour left. So I'm actually making really good time here. Okay, crew component implementation. So here in crew component implementation, not crew, wrong one, trait component implementation, I need to be able to add, remove, whatever traits. Now, I know in here there's also an init function. So that's how components are created. Virtual bool init. Actually, forget the signature for it. Here we go. So I'll just actually do this. Oops. Great. Except of course you are now override and final. Why not? Doesn't hurt anything. Okay, so here's my init. Create implementation. So what does this do? Well, if I go to say my let's do security. Security's great. So if I go to my security guide, this is my entity definition. So when entities are created, they use this. And these are various components that are created. So I'm going to add one in here. Trait component. And I'm going to say this. I'm going to do this. And I have to say type equals trait component. And then anything I want can be in here. And this table gets passed in here. So I can put anything that I want here. So I'm going to say initial traits. Ooh. This will be interesting. Okay, so initial traits equals, and then I just want this to be some array of trait IDs. And so in our case, I'm going to say test tag. Is that what I called it? Where are you? Trait, not trait types. Test tag, yeah. So I'm going to say test tag. So he's going to start with this trait. And so this will just be a way for us to test this. So let's go back to trait component implementation. And so I have this. What are you complaining about? Do I not have these? Oh, I don't have these implemented. Let's implement that crap as well. Generate definitions. I don't. I probably do need a destructor. Finish. Oh god. Okay. So you're here. I have no idea why that showed up on your home screen. If you subscribe to me, that might be why. I'm streaming traits and an implementation in an actual game. That's what I'm doing. Yeah, and I'm actually almost done, so you've missed most of it, but that's okay. Okay, so now that I have this guy going, I guess I can make you final as well. It doesn't really matter. So what we want to do is we want to kill all the stuff that's here, because these trait instances need to be sort of dealt with. I think it's kind of cool that YouTube put it there, though. That actually kind of makes me happy. Okay, trait instance, add trait instance. That's probably right. We'll see what that looks like later. Okay, so for it keeps going here. I also have to change these guys, don't I? That's why this is a pain in the ass and why you should take my advice and not do this particular method. I definitely need to rewrite this aspect of it. Okay, so back to this thing, trait instance, this guy. Okay, so now what I need to do is we'll kill this guy. So for auto pair in traits m traits dot whoops, key value pair dot second, and we'll delete you. And you're complaining trait instance is incomplete. So this is going to be under dot slash traits trait. There it goes. We have to destroy them, of course. Okay, so back to instance. Back to init. So now what I want to do is I want to go through the actual thing, which is basically any of the data that's in, what's wrong, one security, where are you? Any of this data that's here. Right now, all I have is this initial traits. And here's kind of the funky thing. And I'll briefly go over this. Why not? I'm making good time. The initialization path for any component is, it calls a constructor before anything, and then pretty much immediately calls the init function. Then there's a post init. Post init happens when everything has been, all of the components have been added, whereas init does not guarantee that. So I actually have to use post init in this case, because the trait can do any number of things. You know, for simplicity, I think for simplicity, I'm not going to do that though. Okay, so script var initial traits table equals description dot get table var initial traits, and then that's going to give us this sort of initial traits thing, and then I'm going to say if initial traits table dot is table, and if you don't have an initial traits table, that's fine. So I'm not going to fail this, and I could do a check. I could say else if, I've done this before, initial traits table dot is, I'm going to say if else if not this, then then we say initial traits is invalid. Initial traits type is invalid. Plus toStir this guy. Dot get type name. Once again we do this. Okay. So initial traits table. So now what I want to do here is I have this thing. So I'm going to say key, again, auto key val in initial traits table. And this is just a regular array. So I'm going to say key val dot, let's do const script var val equals key val dot get value. So here's the value for it. And then here, so this should be some kind of string. You know, I have other ways that I can sort of check for this, but let's do it. So if not val dot is string, then we do the same type of thing where we say all this crap. This is one that I could also say. So I would say invalid type in initial traits table plus equals val.get type name. Oh god. This is another case where should I fail it? And I probably should. I think this entity just fails. And then here now this is definitely a string, so I can say now I can actually like go into the trait database and all that kind of stuff. So I'm gonna say, before I do this, I need to include slash. I think it's, there you are. I'm gonna include the main logic system. Get space sim logic dot, oh, I didn't fucking create this. Space sim logic. Of course, it would help if I created the accessor for it. Trait database. Trait database. Oh god. Okay. Get trait database dot create trait instance. Based on val dot get value. Whoops. Get table string is specifically what I want. Not table string, regular string. It is a string. Good job. Okay, and so this is going to create the actual trait instance. So we say trait instance star p inst equals, I'm going to say trait inst equals this. If p not p, that wouldn't matter. So I'm going to say if p trait instance, then add trait instance. And for fun, if the trait wasn't created, then there we go. Create and add the instance. And then this one is get the value. So this is going to be like get the array value, I guess. Okay, so we've got this. This is going to have to be moved to post-init at some point, but for right now, this will work because it might have to access other things. Okay, so questions. There's a retracted question, and then there's a macro. You're talking about unused, yeah, so you've probably seen that in a few places. So like if I did it here, unused param p trait, you're talking about this guy, right? Oops, not that. So unused param basically equates to this, and it's sort of slightly different depending. So it's a Microsoft thing that specifically Visual Studio will, if I just have this somewhere, it will treat it as if it is a used parameter, but it's like invalid in Xcode and other things, so this doesn't work at all. Now there is a C++, I think 17 feature, which is like unused param C++. Oh, sweet. I'm glad I answered it. Harvest assigns a warning about unused variables, and it's... Oh, where is it? Oh, yeah. See, they're doing it as a lambda. I find that interesting. This guy, attribute unused. Oh, I can actually rewrite my thing. Here it is, C++17. I'll zoom this in because nobody can probably see it. Oh, that was way too much. C++17 now uses maybe unused. So once I go to C++17, here they all are. Maybe unused. Where are you? It's somewhere. There it is. Maybe unused is specifically meant to suppress these types of warnings, specific compiler warnings on unused entities, if any. And so in the future, once I support C++17, I'll be doing this. And this is actually, if you use C++17, this is the correct way to do it, and because it's standard. And you don't have to do all this other kind of like bullshit that's going on. And again, this only works in in Visual Studio, hence the ifdef. So this is terrible. That's what it is. That's what it equates to things that are terrible. But it suppresses the warning, so that's fine. Okay. These didn't get changed in time, so let's change that and change that. So I'm going to implement these real fast. These should be pretty straightforward. Right now, this is a hash map, so it's literally going to be traits dot in place, and I don't have the ID. That's fine. Ptrait dot get ID and ptrait. That's it. And because I should never actually be doing this, but I might do it at some point, I'll just do a quick assert here. Okay, so remove trait. Mtraits dot, I'm literally just gonna call remove, I think. Oh, there's no remove. Erase. I think I'm literally just going to do this and take the easy way and not care whether or not it was actually removed. I might change this to like check to see if it's removed and return true or false and all that stuff, but I don't really care right now. I'm just doing the easy thing. And then this one I do actually care. This is what I started writing before. Find it equals mtraits dot dot find trait ID if find it not equal to m traits dot end, and I should be doing this more constantly because I don't no, because you can modify this, so I guess I can't do this as a const thing. Then I want to return find it dot second. Otherwise return nothing. We didn't find it. This can be const, however, and that's it. These are the implementations for these guys. I should now be able to attach these things. What are you guys complaining about? Definition for add trait not found. I feel like it just hasn't caught up with the fact that I've actually written this. But we'll see. This may fail. Oh, cool. I accidentally changed something in some top-level system file, so it's going to build a whole bunch of stuff. I have no idea what I changed. That's always fun. Well, it's going to build for a while. The hope now is that when it creates all security officers, they will all have this particular trait. So that's what I'm hoping. Mostly I'm just trying to build this to see if it actually works. We'll find out eventually. Almost done. Yeah, they're the red shirts. Almost done. Or maybe not. I must have accidentally like hit a button in some I'll bet I did. I'll bet I know exactly what I did. I bet I accidentally pressed a button in here and like made some like white space change in macros.h, which is going to cause a complete rebuild of pretty much the entire engine. So you get to enjoy my build times. That's what's going on here. Well, there's more. So there's sort of more work that has to happen to make this actually work, because I have to tie the trait system in some way to like gameplay and to the script. So if I go back to, where was I? Trait component. This is what I want. If I go back here, what I'm actually going to do is I'm going to set a breakpoint here just so that I can make sure that this is actually like happening the way that I would expect. Camera follower, camera alert process. We're not even in the game yet. We're still in the engine. I definitely accidentally changed something in macros.h. Cool. Well, this is the pain of a live stream. If this were a recorded video, I would just cut this part out. I want to say on The Sims we had something like 20 or 30 minute build times. I actually kind of don't remember. If I had to rebuild the entire game, I would go to lunch. And that's not even anywhere near the worst compile times I've ever seen. Okay, here we go. State machine. Oh no, yeah, main space sim. Okay, this all looks like game stuff, so this should be done pretty soon. So I still have to connect this to this scripting system so that the script knows what traits are. And I think once I do that, that's about it. You're almost done. You can do it. There it goes. This is even an SSD too, so that's a while. Okay. And load and run. Unknown implementation ID. Oh, son of a bitch. That would help. Big thing I forgot to do. Oh man. Where are you? Components. Here it is. Components are created through a factory. Maybe I should add it to that. So trait, I'm gonna space sim. No, that's fine. Trait component implementation ID. Trait component. So I just have to add this. Let's see. Yeah, this is right. Oops. I don't have a fancy S switch for this thing, so I got to do it this way. Equals new trait component implementation, and then that should be all I need, except of course I have to. Oh, there it is. It's right there. New trait component implementation. Okay, I've missed something. What have I missed? Not you. Yeah. Wonder why you're complaining. Default constructor is deleted. Oh, okay. What's default constructor? Entity component ID, interface ID. That's why. Okay, so it's been a while since I've created a component, so I actually have to do this. I forgot I had to create this thing. So every component has to have, so like if I go to, where's the room one? I was looking at room as an example. So if I go here, I have to create some kind of interface ID. So I'll do that briefly. I totally forgot I had to do this. And then I just have to create a GUID of some kind. Doesn't matter what it is. So I actually just go to Tools. It's somewhere in here. Create GUID. New, copy. And I just paste it in here and grab this guy. Oh, it's a small one. Okay. And then I have to pass it in. And then it does all the registration stuff that needs to happen. There we go. That's fine. Totally forgot that I had to do that. Oh, and hash map shouldn't be here. Cool. Maybe it does need... Oh, it needs to be in the implementation. Now that I've removed this. EASTL. No, not bonus. Hash map. And this should be good. Yay! Okay, so now let's run it and hope that we don't get any crazy runtime errors. Load. Run. And here's my breakpoint. Great, this is what I want. So we'll step through here. Key val. This looks good. The actual value, well, I can't see it here, but I can create this instance. So let's do that. So create instance, it created an actual instance. I'm gonna go in here. It only has a definition. It's a social thing. I go in here and dig through this guy. You guys probably can't really see it. I wonder if I can zoom in. Yeah, that wasn't super great. Okay, but we'll just do this again. ID, data, pair. Oh man, it's in one of these guys probably. There it is, test tag. So yeah, this is correctly applying my trait. Okay, well, it's 11:26. I said I'd do about a 2-hour stream, so that's about right. The system's not finished, but the core idea is there. And so now, you know, the big things that I need to do, you know, there's a SpaceSim script component. So like really all I really need to do, in fact, I could actually just crank this out. This is going to be like 2 seconds. Trait component. So if I go to my trait component, these are the major things I want to be able to ask. So I will basically just copy and paste these functions. These are just pass-throughs. I'm not going to be able to get the trait. I'm going to add and remove a trait by whatever. How do I want to do this? I'm going to probably do it by string. And I think I do want to create some kind of like has trait just for fun. Something like this. Lua doesn't know what a string ID is, so I have to do this by trait ID. By, you know, I have to do it this way, which is not ideal, but such is life. I don't know if I actually want to do this. So what I'm going to very briefly... I don't want to do this. I want to kind of test this out in some different way. Yeah, it doesn't matter. So one way is to, like, I need to hook up these functions to the script. I guess I will do has trait just so you can kind of see what it looks like if you're curious. I just have to create these sort of glue functions. Trait component. And so for this guy, I would just sort of create this function. And then all I'm doing is I'm grabbing the appropriate component. Trait component, I don't have to include it. So trait component, and of course I need this to be a weak pointer because they're all weak pointers. P trait component equals, now I can basically, np owner, come on, dot get component, trait component, colon, interface ID. And then, you know, I'm basically copying and pasting this. Like, it's the same idea. If not this, then no trait component on some entity by some ID. I'm going to return false. That seems reasonable. So now that I have the actual thing, I'm going to say trait instance star p inst equals p trait component dot get trait. Oops, by trait ID. I'm going to return p inst not equal to null pointer. And you know, it's that simple. I just do this kind of thing. The last thing that I would do here is I would have to then add it up here. And so I would say just has trait. Has trait, and that's it. Now it's exposed to the script. Now if I have like an entity ID or an entity of any kind, inside of the actual scripting interface, I can ask if it has a particular trait. So let's do that with, what was it, simulation? I think it's yeah, there it is, simulation object. So like here I have this sort of get name, which is, you know, get a bunch of like debug name stuff. So get crew debug name or whatever. So else, let's say, let's do local name stir equals nothing. And then I'm going to say name stir equals that, else name stir equals that. And then I'm going to say like if self dot, this is Lua for those who have not really ever seen this before. if self dot owner has trait test. I don't know why I don't remember what this stupid trait is called. Test tag. Then, we'll just add namester namester equals namester red shirt or whatever. So hopefully this will just run and not blow up on me. Load, run. Great. So this is going to keep sort of spamming, but actually I can just stop this. Okay. So if I go here and I click on like a blue guy, click. Oh no! No trait component. Oh, you suck. That's fine. And I get a little exception. That's great. We'll ignore that. We'll pretend that didn't happen. But we'll click on this red guy. And nothing happened. What are you doing? Do I have to run it again? Yeah, okay, I guess. No, it's still going. Okay. Yeah, it's breaking. It's breaking because, so short version is I have no direct way to determine whether or not this thing actually has a thing. So anyway, has trait component. I've had to start doing this on some of these things. I have to basically test if this thing has the component at all, because although arguably this isn't an error, it's just a false. So maybe I can actually just do this. Hi. Oh, sure. I'm probably not going to use that. Okay. Great, I'm going to stop this. You bastard. Component generators. Concatenate a nil value. That's interesting. So that means name string is probably nil here. Shouldn't be. I don't know why it would be. So now it shouldn't be nil. In fact, let's force the issue. Name string equals name string or error. We'll force the issue. The name string equals name string dot dot that thing if I have a trait. Right, this 2-second demonstration was supposed to be super easy, and it's turned into something less easy. Alright, so let's click on a red guy. You bastard. Alright, well, screw it. There's something wonky going on here, and I don't know why it's like in component generators, so I'm not sure why it's breaking here. Oh, of course. Now that I've done this, I have to actually return it. Nice. I hate it when something's stupid like that. Okay, load, run. I'll bring this guy back over here. That would be why it's in component generators. Okay, so click. There we go. And look, it even says it. There he is. He's a red shirt. If I click on this guy, I don't get the red shirt message. So that's how you would sort of hook this stuff up. I'm mostly running out of time. I'm going to keep doing this kind of stuff, I guess. I don't know. So, some of you have left and some of you are still here. Let me know, like on Discord or wherever, send me a message. You can comment on this, whoever's here. Let me know if you want me to keep doing this kind of thing, if you found this useful, if you found this fun. I actually didn't find it that much less sort of optimal. Like I probably could have written all of this code in maybe half the time or like 2/3 the time. So it wasn't actually that thing. It didn't take me that long to do this kind of thing. It's also great, I think, because like I'm not just coming from nothing. Like there's an actual system here that I'm trying to build. I'm seeing general like yeses and positives, so that's good. Yeah. I don't know what a good cadence is, if it's weekly or whatever. I mean, this is a project I'm actively working on. So the tricky thing is like probably I'm going to work on it tomorrow, and like I'm probably going to spend the day working on it, and I'm probably going to keep working on it like tonight because I still have shit that I got to do. So, you know, I don't know what I'm going to do in terms of the conclusion of this. I might have some like wrap up video or something where I just talk about, you know, what changed. But overall, like, I'm glad that you guys found this interesting and found this fun. You know, it was cool to kind of go through this nice little sort of self-contained thing. Yeah, I'm hoping you can directly apply this to like various classes and things that you're in. That's a strong hope for me, that you guys can like directly apply at least some of it, or even if nothing else, like, you know, just some of the like I only have one here. Just some of the thinking of like, well, how do I kind of think through some of this? And this is a relatively straightforward system. And then realizing like, oh, how did this change? Like I don't have a single trait class. Now I have sort of two, and see how some of this stuff can work. To seeing how it can change in implementation. Yeah, everyone hits errors. Sometimes there's stupid errors. But yeah, no, we all get errors. That's one thing that I found. A friend of mine has taught like new people how to program, and she says one of the things that she runs into is people get like flustered by the compiler, and it's like the compiler's not yelling at you, like, you know, it's just a tool, and we all have errors. That's definitely true. Oh, like in typing, yeah. Oh God. I mean, you should know that just by taking classes with me, because I sort of live code there, and I'm just terrible at typing, apparently. And I get in zones, and like one thing that happens is like, you know, when your keyboard is shifted slightly to the side, and so now you're just like completely off, and so you have to like readjust how you're sitting. It's fun. It's fun how all that works. You guys are probably like I'm gonna keep going on this stuff. I can do more of these types of things. I think I'm glad it's useful. I think the live stream seems like it works really well. Which is really nice because you guys can sort of like ask me questions as I'm writing, as I'm sort of going through this stuff. So that's really nice. It's also kind of nice because it takes an entire massive step off of my shoulders, which is really cool. And that massive step is editing, because I don't have to edit anything. I just type. Cool. Okay, yeah. I mean, the next major thing is to, since this all seems to be working, is to go back and actually create the functionality that I'm creating the trait system for, which specifically is trying to add schedules to entities. And there's a few things I have to fix. There's actually one thing I meant to do, which I'll do right now, because I'm not going to remember if I don't do it, which is this guy. I'm going to say initial traits, and then I'm going to say to do move into post-init so we can access other components. But it's like an extra layer to do that, so that's why I just kind of slammed it in here. All right, you know, you guys can hang out if you want. I'll hang out for a bit if there are any other questions or anything that you guys had, like questions or whatever for. You know, there wasn't any like super interesting like engine level stuff that I went over here. This is all like a very self-contained system, but I'm happy to answer any questions that you might have about stuff. If people want to hang out, I'm happy to just sort of keep going. Like, I don't know, 2 hours felt like a reasonable amount of time. I don't know what you guys want to do. I guess it's up to you guys. Like, my plan was probably to just keep doing this. Let's see. But I'll probably keep doing this after a break of some kind, because I should do something. I have no idea why it showed up. So one thing that I did that was different about this stream than all the other streams is I made it live. Like a public stream, so anyone can see it. So if he has a significant interest in programming, it might have just auto-populated on his homepage. That's my guess. I actually did this. I have like a very tiny sort of following of I have like 115 followers or something like that, like on YouTube. And so I'm just like, if any of them happen to be awake, like maybe they'll get some notification and pop in. I don't know. So I decided to make it public. But yeah, I guess he just showed up and then bailed. Or maybe he's still around. I don't know. I'm sort of curious for people who didn't have the context of me like announcing this on a Discord that you guys are all on, what it was. But my guess is that coming into a stream like 20 minutes before it ends probably wasn't going to be super useful for him. 139, that's cool. I don't know what I'm going to do with that. They keep asking for more ECS videos, and it is a non-trivial task to keep working on that. But I'll definitely like work on that stuff. Yeah, the other streams that I did were very I just streamed what I was typing, and it seemed less useful because no one had context, and so it's easier if I'm talking because people have context. So it seems like that's universally a big win. So I guess I'll definitely keep doing that. So that's cool. Yeah, 139. That number went up. 139 is much higher than the last time I checked. I feel like I in the last few days must have gotten several people subscribing. Usually I get people subscribing and then they comment on one of my ECS videos asking me when I'm going to do more ECS videos. Well, the answer is soon. I actually just rewatched all 3 of my ECS videos and went through the old code demo to figure out where the hell I was. And so my hope is to do that fairly soon. But the next Unreal AI video is already basically posted. So it'll go live on Thursday. All right, guys. Well, that was fun. Thanks for tuning in and hanging out. It seemed like it was super successful, and it seems like everybody got a lot of really good stuff from it. For those of you who I know more personally, I'll see you at school and in class and all that kind of stuff. Let me know if you have any questions. Let me know if you have suggestions for other things. I can stream other things that are like this, other systems as they become interesting, and other little videos. So just let me know what you guys... and one big thing, the big question that I have is the cadence. Should I just kind of do this whenever I happen to feel the urge and just say, hey guys, I'm going to stream in a couple hours? Or would it be more helpful if I just said, okay, every Monday night at 9:30 or something? Like if I just said this time, every week. Let me know what would be most useful, like just a weekly cadence and I'm just going to stream whatever I happen to be doing that day, or if if I should stream tomorrow, or what would work. Both doesn't answer my question though. I should just stream whenever and then also have a weekly cadence of when I do this. Is that what you're saying? That might be good. Yeah, that I can always just say, hey, I'm gonna I found this interesting problem. If anyone wants to check it out, here you go. But yeah, I don't know if it's hey, tune in next week for another episode of the trait component implementation, or if it's today this is what I'm doing. Well, Dylan's in my class now, and I can definitely attest that he does not yet know everything. He's on his way, though. He's close. He's pretty close. Yeah, if I'm able... It doesn't actually cost me that much to stream, so, that's the thing. It costs me something, but it doesn't cost me that much, because I can just... It just means that I have to, actually sit down in front of the computer and not be, distracted by other things, and I can't just, walk away for an hour. So there's a cost to it, but not a significant one. So I don't know. I'll figure it out. I still haven't figured it. I may or may not be coming into school tomorrow. Depends on this rehearsal that happens. But if I'm not, then I will probably just try and stream tomorrow at around the same time. And I may just try and finish this trait component thing. So I may just bail on it today, work on something else for the rest of the night, and do the trait thing tomorrow, so that we can actually finish this implementation. Because I think that would be super beneficial. Because there's a big piece of this that's missing, which is how do traits actually affect entities. And so I think I want to add a couple of effects and just sort of show how that stuff would work. And, obviously for myself, this is what I would do normally, just to have my own proof of concept of like, how does this work? And then from there, say, okay, I guess that's it. And, call it at that point. So yeah, maybe I'll do that. All right. So, why don't we say that? Why don't we say tomorrow? I don't know if you guys have class or whatever, but let's say tomorrow at about the same time at 9:30. Would that work for you guys? I think that's a reasonable time. So I can just set that up and just sort of work on other stuff until that point. So let's do that. And I don't know if there's any last minute comments or things. I think that's pretty much it. And those of you who are normal people can go to sleep because it's almost midnight, and those of you who are crazy night owls like me can begin your day. Class? What class do you have? Oh, it's probably Bill's class or whatever. That's fine. I can you can watch the recording and then let me know as well. And jot down any questions. If you do have questions, let me know. That's an epic recording, dude. That's gonna be like a 2-hour recording though. Although I guess if you jump into a live stream, I don't know if it starts where it's going or if you can start it over. I feel like there's some way that you can start it over. And if it's better for people, I can actually do the stream later. Like I could do it at 11 if that's 11 p.m. I'm up forever, so it doesn't matter to me. If later is better for people, I can do it later. So that people are out of class, like guaranteed people are out of class at that point. Yeah, I figured you could probably start over and then let it just sort of go and then basically catch up to it. That's what I assumed. Germany time. Yeah, that's right. I just set it up in Germany time. Later is better for you. For some people, earlier is better. I have a couple of online students who are here. I think when this thing started, I was around 9 watching at peak. And I think that the people who dropped out are a couple of the online students who were like East Coast. One dude came from Phoenix, so that's 1 or 2 hours ahead. I don't actually remember. Yeah, later's better. I mean, it doesn't matter to me either way. Certainly evening is better because I usually do like sort of academy director stuff in the afternoons and evenings until around 5 or so, and then everybody, like the academy basically like the executive office shuts down at like 4:45, and so once that happens, like there's nothing I can do, and I just work on my other stuff. All right, guys, I'm gonna answer the like 5,000 text messages that I got during this time, and kill the stream, and yeah, just hit me up on Discord or whatever if you have any other things. Thanks again for tuning in, and we'll do this again. I'll see you guys next time. Thanks.